guys, welcome back to the DU EVS course. Today we are covering the topic Nuclear Energy, Chapter 5. So now we are going to dive deeper in this topic to understand it better. Defining the nuclear energy. Nuclear energy is the type of energy which is used to generate electricity through various nuclear reactions. They can primarily be divided into two, namely nuclear fission and fusion. Nuclear fission, it is a nuclear reaction in which the nucleus of an atom splits into two or more nuclei. A large amount of energy is released in the process. Nuclear fusion, it is a nuclear reaction in which two or more nuclei are combined to form a single or more atomic nucleus. It is the opposite of fission, that is, it doesn't release large amount of energy. Nuclear hazards. Nuclear energy can be used to generate commercial energy or to create weapons of mass destruction. It has tremendous potential, but there is always a chance of leakages which can be devastating. Thus, it has both benefits and risks associated with it. When the environment, that is air, water, soil, gets contaminated with radioactive materials, it is believed to be a nuclear hazard. If we talk about our day-to-day life, radiation is prevalent all around our environment. In the tiniest of appliances, such as mobile phones, microwaves, X-rays, etc., it becomes a concern for us when the radiation level exceeds a certain amount. Radioactive radiations are, however, believed to be the most harmful radiations. Radioactive substances are present in nature. They undergo natural radioactive decay in which unstable isotopes spontaneously give out fast-moving particles, high-energy radiations or both, at a fixed rate until a new stable isotope is formed. The isotopes releases energy either in the form of gamma rays, high-energy electromagnetic radiation, or ionization particles, that is, alpha particles and beta particles. Understanding the sources of nuclear pollution. They can be natural or be man-made. Natural sources of nuclear pollution are cosmic rays from outer space, emissions from Earth's crust, soil, air, water and food which contain one or more radioactive substances. Man-made sources of nuclear pollution. Some appliances in the medical industry use radioactive isotopes. Mining and processing of radioactive ores. Nuclear testing, done either underground or beneath the oceans. Effects. The effects of nuclear radiation can be devastating for not only human beings but other creatures as well. Generally, alpha particles are considered more harmful if they contaminate food than beta particles. This is so because they have more energy than beta particles, but their permeability is less. The impact of nuclear hazards on human health can be divided into two. Somatic, cell and organ functioning is affected. Damages the cell membranes, mitochondria, which result in stunting of growth and in some cases death. Genetic, DNA molecules are affected, may cause permanent mutations in genes or even blood cancer. Chernobyl Disaster. The Chernobyl accident occurred in Ukraine in 1986. It was the result of a flawed reactor design that was operated with inadequately trained personnel. The result of the accident led to explosions and fires. It caused a lot of damage to the environment because of the addition of radioactive materials in many parts of Europe. The two workers who were operating the plant passed away on the night of the accident, and around 30 people died due to the acute radiation syndrome. Some other facts in the Chernobyl disaster. Some 350,000 people were evacuated as a result of the accident, but resettlement of areas from which people were relocated is ongoing. The United Nations Scientific Committee on the Effects of Atomic Radiation has concluded that apart from some 5,000 thyroid cancers, there is no evidence of a major public health impact attributable to radiation exposure 20 years after the accident. Now, the management of radioactive waste. In order to avoid unfortunate disasters, it is essential that radioactive waste be treated and then dumped. Nuclear reactors should be restored and allowed to decay naturally in closed drums. Laboratory generated nuclear waste should be disposed of safely and scientifically. Nuclear power plants should be located in areas after careful study of the geology of the area, tectonic activity, and meeting other established conditions. I hope the topic is clear to you. If you have any doubt, please comment, and for more detailed notes, visit our website hrcharitima.com.